All right, hello, welcome. We're going to be working on 7.6 surface area still, but this time we're going to be working with pyramids. Okay, so here's a pyramid. Think of the Egyptian pyramids, okay? Pyramids have a single base, and then they have triangular tops. So in this book, the base of every pyramid is either a square or an equilateral triangle. So in other words, all the sides are going to be the same. Okay, so next year we'll get into some other stuff. But anyway, so we're going to have squares or equilateral triangles are going to be our base. So a pyramid is, if you look at this over here, it's got this square bottom, okay, and in this particular one, it has, therefore, because it has a square has four sides, it has coming from it a triangle that gets folded up that comes to a point, okay? And the point we will use, okay, when we're dropping our altitude and we're trying, so all we're going to be doing is we're going to be figuring out surface area of the base, okay? And in fact, the basic formula I use is the surface area of a pyramid, just like the prisms, is the bases plus the faces, right? Well, in this case, we have one base, so we'll call it the base plus the faces. All right, so hopefully that fact that rhymes helps you remember it. But with all of these prisms, pyramids, and stuff, you're just adding the area of the bases plus the faces. Okay, so let's just pretend, for the fun of it, just to make it easy, let's pretend this one, the area of this bottom was 4, my base, and each one of these was 2. Okay, so then I would just take, okay, well, the surface area therefore is the base is 4 plus this 2, but how many triangles do I have? Well, I have 4 triangles, so 4 times 2, that is 8, so 4 plus 8, the surface area is equal 4 plus 8, so therefore the surface area would be 12, okay? So it's really that simple, at least this problem would be. So let's check a couple real ones out. Okay, so this is example 1. We're going to find the surface area of a square pyramid. So notice that I'm looking over here, that the base of this pyramid is a square. Okay, it's not the triangular one, so we're going to call it a square pyramid. And so therefore we need to find surface area. That's what it asked for. So the surface area is the base plus the faces. Bases plus the faces. All right, so surface area, therefore, of the base. Well, what's the area of a square? It is the side of the square, which in this case is here, is 7, right? Squared. That's where we get squared, because length times width is 7 times 7, which is the same thing as 7 squared. So our base is 49, because 7 squared is equal to 49, yeah? Okay, so now how many faces do I have? Well, I have 4 triangles, right? So I'm going to multiply 4, and the area of those triangles is 1/2 base times height, because that is our triangular area formula. Okay, so surface area is still equal to 49 for my base, and it's still equal to 4 times 1/2, and now let's identify here, okay? So we're looking over here. We have a base. Well, all the sides of a square are the same, so our base is 7. And our height, which is taking the altitude from the point, okay, down, or better yet, it's called a slant height, because this is at a slant from the tip of the pyramid all the way down to our base, and then we draw a right angle. That altitude there is called the slant height, and it's 10. So let's get moving here. Okay, and then that's still in parentheses here. So we're going to do this part first. So, well, we already have the 49, and then we're going to multiply 4 times whatever's inside of these parentheses here. Okay, so 1/2, I'm going to use commutative property, and I'm going to say, okay, well, 1/2 times 10, 1/2 of 10 is 5. 5 times 7 is 35. So it is 4 times 35. Apparently we're changing colors. Surface area, therefore, is equal to 49 plus 4 times 35. Let's see. 4 times 35 would be 20. 140. Let's go ahead and use calculator to be sure. 140. Yep. 140. And therefore we add these two together. Well, 40 plus 49 is 189. And we have meters. And because it is area, we have to use meters squared, remember? Okay. So, next problem. Okay, so now we're going to look at this. And in this one, we have a triangular pyramid. So much like the prisms, they are defined by the base that they have. Okay, so in this case, our base is just this triangle down here. Okay, so that's the base of our triangle. Therefore, it is called a triangular prism. So we need to know, again, the base plus the faces. Okay, so that will be our surface area. I always forget to label it. So surface area is equal to, well, a triangle is 1/2 base times height. So are the faces, but in this case, how many faces do we have? Well, we have 3. So you know what I'm going to do? I'm going to go ahead and say 3 times the 1/2 base times height of each one of these faces. Okay? In fact, just for fun, let's change these to blue so we can remember the difference. Okay, so there's 3 of them times the 1/2 base times height of the blue part. Okay, now GEMDAS helps us here. Okay, so remember, we're gonna have to do this inside. Sorry, we're gonna have to do this inside and then multiply by 3. Okay, because it's in parentheses. All right, so let's go. Let's go back to back. Surface area is equal to 1/2, and now we're looking at the base. So we're looking at this thing right here. The base here is 6. Okay, notice I just choose not to use the net because the nets are generally not provided. If they were provided every single time in all situations, I would. And then the height of this is this right here. So it is 5.2. And let's go ahead and add our faces too. So we have 3 times 1/2, and what's the base of this? So we're looking at this side, right? Like this triangle. So the base is going to be this line here, and the height is the slant height, as they call it, is going to be this right here. So the base is So the base is 6, right? Because all of these are 6. Okay, so we have, I'm sorry, I lost my 1/2. Oh, let's undo that. 1/2 times 6 times 8, right? Okay. So let's see what we've got. So the surface area of the bottom part, the base, is 1/2 of 6 is 3. 3 times 5.2. Use my calculator. Let's not make the same mistake though, and make sure this makes sense. So that should be 15.6. That makes sense to me. And that is our base. So now we just need to add in the faces. So we're going to, first we're going to do what's inside the parentheses. So 1/2 of 6 is 3. 3 times 8 is 24. So we have 3 times 24, right? Okay, so 3 times 24 is equal to 72. So we know that this right here is 72. And now let's finish this up. And we have our surface area is equal to 15.6 plus 72. Calculator, surface area is equal to 87.6 feet squared. Remember, surface areas are always squared. Okay, now let's see here. We are over here now. So in this one, we're going to do a real-life problem. So this says the uppermost piece of an ancient Egyptian pyramid is called a pyramidion. These square pyramid-like shaped pieces, were sometimes covered with gold. So if I wanted to take this thing here and cover it with gold, top, bottom, sides, all that, with gold, what is the least amount of gold I would need to cover it? And then it's going to give us the dimensions of it. Okay, so it tells us that the triangular face has a height of 1.2 meters. So as you can see, they've drawn this, and I went ahead and left these in, but we could have easily drawn this ourselves, right? It has a height of 1.2 meters and a base down here, or over here they show us 1.5 meters. Okay, so this here is 1.5 meters. So therefore we have so when we're covering it, all right, covered with gold, that means it's surface area, which is what we've been doing. So the surface area is equal to the base plus the faces, right? I'm going to run out of room in this scenario, so we're going to do a story problem. Okay, so go ahead and sorry guys, let's go ahead and come back down here. Okay, so the surface area is equal to the base plus the faces, right? Okay, so surface area is equal to, well, let's look at the base here is the square base. So therefore it is 1.5 squared, or 1.5 times 1.5. Length times width they'd be the same, so it's the same thing as multiplying it by the same thing or squaring it. So we call it side squared. Okay, so the bottom is going to be side squared, and the faces, well, those are just going to be triangles, which, how many triangles do I have? 4. And I'm going to multiply that times the 1/2 base times height, which is the formula for triangles. And then that should give me my surface area. Okay, so let's finish this up. So surface area is equal to 1.5 squared. I don't need to write that. We'll just do it on my calculator, which gives me 2.25, which I should have known, but anyway. So, and then 4 times, well, let's go ahead and write this out. So 1/2 times the base of the triangle. So let's look at our triangle here. The base of our triangle was 1.5, and we knew that. And then this slant height, which is right here, right, that comes to a right angle, I'm exaggerating, is 1.2. So 1/2 times 1.5 times 1.2. Okay, so I'm going to take 1.5 on my calculator times 1.2, and I'm going to get 1.8, and then I'm going to take half of that, or divide it by 2. Another way to do it would be multiply it by 0.5, right? 1/2 is 0.5 as a decimal. I'm just going to divide it by 2, because taking 1/2 of something is the same as dividing by 2. And this whole thing is 0.9. So 4 times 0.9 is, times 4 is, 3.6. So let's finish this up. So this 2.25 should have come down. Surface area, therefore, is equal to 2.25. And there was a plus here. Plus 3.6. So let's put that into the calculator, and we get a surface area of 5.85 meters squared. And again, that is how much, that is the least amount of gold we would need to cover this pyramid. All right, thanks guys, have a good one.